Today we're running a lesson on bearings. We're going to have a quick recap of some of the key points, the key facts behind some of the maths, and we're going to go through a few worked examples. Okay. So on the screen on the left-hand side, you can see our compass points, our directions. So if you pause the video here and complete the compass points, where do north, south, east and west go, for example, and the ones in between. Want to replay the video, and at this point I'm now going to work through those answers with you. Okay, the most important one, especially when we look at bearings, is where we mark in the north point, this one. That might not be stated in words, but the north point will come up in every bearings question. Okay, and is very relevant. Okay, and then you have the south, which is the opposite side, and the east and the west. Right, in between those, we've got the northeast, and we've got the southeast, and the southwest, and the northwest. Okay, north and south being dominant, that they sit in front of that. Okay, and we'll come back to that one in a moment. On the left-hand side, have a think about what clockwise means and what anti-clockwise means. Now let me show you here. Clockwise, as you might imagine, is like a clock, and it goes around to the left. Clockwise is the direction that we work in with bearings, and anti-clockwise goes back the other way. So on this page, you can see that we've got the north line, which is very important when it comes to bearings, and the fact that it goes clockwise is the other important factor. Okay, so any measurements that we make using bearings, we would start at a north point and we will always work around clockwise. So if we were to go from north around to south, that's 180 degrees. If we went past that, if we went all the way around to west, that's 270 degrees. That's all based on the fact that going around the whole circle is 360 degrees. So let's move on to the next slide. And I've just given you a bit of a clue for this one. If you don't know this one automatically, need to do a bit of revision, post-it note in a prominent place in the house to remind you that there are 360 degrees. That's the unit of the angle that we measure around a point, so around a circle. Okay. We'll look at the next question. So we've got our circles chopped up into your north, south, east and west. How many degrees are there in a quarter of a circle? Pause it now if you want to have a think about it. Okay, it might help if I draw this little symbol here. There are 90 degrees in a quarter of a circle. Half a circle. Again, pause it if you want to think about it, but that's 2 lots of a quarter, so it's 180 degrees. Knowing these facts will make work within bearings a little bit easier. And if you know that you tend to trip up on these, maybe a bit of practice before you go on to work with bearings would be sensible. Okay, so on the next screen, I'm going to give you a diagram to think about. Pause it in the video and have a think about what you know about that line and anything that relates to it to do with the line and the angles. So unpause the video, talk about it here. Now we mentioned earlier on that pointing upwards is north. So when you see a diagram with a black arrow with an pointing upwards, then that is telling you that that is facing north. The other factor we touched on just now is the fact that if you go clockwise around from this point, that gives you 360 degrees. Okay, next point, let's have a look at this one. Bottom shouldn't really have an arrow on it, but okay. What can you tell me about this one? Pause the video if you need to. I will continue. Again, that's north. Now we know that the opposite end is south. And the other factor that we looked at just now is that half a circle is 180 degrees. So if you have a change in direction from north to south, you're turning 180 degrees. Okay, next one. Pause the video if you want to have a think about what you see. And I will continue now. What you might notice on here is that you have two north lines. And in between you have two spaces or two angles. So we've got this one here. And we've got this one here. Is there anything that you know about those two angles together? Okay. Well, this one plus this one add up to 180. You would be expected to know that. Okay. So you might be given the pink angle and you might have to then work out the yellow angle to then work out what that angle is, for example. So knowing that rule of the pink and the purple, that they add up to 180, could be key in being able to answer some of the questions. So let's have a look at the last diagram on this page for the moment. So what do you know about this one? If you want to have a think about it, pause it, but I will continue. I'm going to continue this from the previous drawing. We've got two north lines, so we've got two different towns or locations, and pointing up is facing north. They're parallel, as per the last one. So if I was to show parallel like that, normally, would see it like that. But because you've got the arrows at the top, you would be expected to recognise that they are parallel lines because they're both facing north. And again, let's put our colour in. We know that this one plus this one adds to 180. So let's just repeat that rule. Okay. But what's the rule from here to here? You might want to have a look at this rule up here. Look, it's the same rule. Okay. Well, that angle adds up to 180 also, which means that this angle must be the same size as this angle here. Okay, you need to be able to recognise some of these angles and some of these skills to be able to successfully answer some of the bearings questions. Okay, you can pause it here if you want to process the information that you have or make some notes, but I'm now going to move on to have a look at a couple of bearings questions. On our picture here, and we've got a diagram that shows part of a map. We've got a north line at the tower, and we've got a cross further down that says the church. And the question is asking you to find the bearing of the church from the tower. So, you notice there I've drawn in a north line at the church, so I've created my parallel line straight away. Okay, and let's have a look. And we're going to draw a line between both of the destinations because we're looking at the church from the tower. Our key point here is that we're going from the tower, and that means that we're going to measure at the tower. Okay, so that's really significant, and we'll talk about that again in a moment. Where you're heading out from, where you're leaving from, is where you use the north line. So I've just replicated that angle on a website and brought that across for demonstration purposes. Okay, so as you can see, we've got our north line at the top there, And I'll just draw the little north line here at the church at the bottom, and that's our tower here. And now in terms of using the protractor, let's bring a protractor in here first of all. If you can have a look, on here, we've got the edge of our protractor is there. Okay, that's just the edge of the practice. Sorry, it's just the edge of the plastic. The part that we are particularly interested in is that first line, definite line that goes up through here. And this point here is our central point. So if I go backwards a step, where I've drawn a little dot there is exactly where we put the center of our protractor. Okay, and it's really important that sits neatly on the joint of both of those lines, okay, on that angle. Right, now if you have a look here, our protractor, if we go up to the top, our protractor has got 180 sitting on the line, and that's not really what we want. What we want is a 0 on the line. Now, a lot of protractors will have both. They'll have a 0 on the outside and 10 and 20. They'll have another scale going round, and where most of the errors tend to be made with reading angles is where a student or mathematician has used the wrong scale on their protractor. Okay, so that was also at 90. So the way you decide is you find the line. For example, you find your line, the vertical line going up, and where that reaches a 0, that one there is the scale you're going to use. If you look at the 0 at the bottom, that doesn't sit on your line. So you need to go up to the top and follow that one round. So if we go all the way around the top, so what we're going to do though is use a simpler one to actually read it. So this is the one that's been printed properly for you. But that's what you would do if you've got both scales on yours. Right, okay. So here on our 0, we follow all the way around. Remember, we're going clockwise, little diagram on the left there to remind you, all the way around until we meet our journey line, which is down here. So the journey from the tower to the church is 120 degrees. So that is our bearing. Okay, so that's how you use your protractor. So let's have a look at another question. After you have a look at these two. So what is the difference between these two questions? You can pause the video here and have a think, or watch it through and I will explain it. So if you have a look here, the key point that's being raised here is that you must use the north line where it says from. So, for example, on this one, it says from A. So you use the north line at A and you go clockwise from A. On this one, it says from B, so it means we use the north line from B. Okay. It may not state from, but you have to think about it logically. Where are they walking from? It's not where they're going, it's where they are walking from. Where are they leaving from? So let's have a look at that in the context of an exam question. So on here, let's read through the question first of all. Ben is an activity leader. He's planning to build he's planning a team building event for a group of people. Ben has this part of a map. So that's your context. You've got a picture of map with A and B. And the key for the map says 1 centimetre on the map is 1,000 meters on the ground. The diagram is drawn accurately. The group will start at point A and walk directly to point B. Ben needs to write instructions to give to the group, and the instructions need to include the bearing and the distance to be walked. Your task is to write the instructions for the group. Remember to give units with your answer. Okay, so let's have a look at the first part, shall we? So we're starting at point A. So that tells us it's from A. So our starting point for measuring our bearing is at this point here. Okay, we're going to walk to point B, and that's where you use your ruler to draw a line between the starting point and the finishing point of the journey. Okay. The next part of the question is to ask for the bearing. So we'll bring across our protractor here, and we'll sit the center point of the protractor on the edge of the line, and it's horizontally sitting on your north line. Okay. Now remember, we're going clockwise, so we're going this way round, and we follow our scale all the way round, and we've got a bearing of 110. Okay, we don't use the blue scale, 180. We need to start at 0, not at 180, and we always start from the top when it comes to bearings. So coming all the way around, our reading is 110. So let's just pop that on there for the moment. So we do have our bearing, and the next part says the distance to be walked. Now this requires a certain amount of knowledge on scale drawing. So let's measure first of all the length of our line. That would start getting you some marks. And our line, make sure that you've got the right point of the ruler. Sometimes our rulers have a little bit of plastic at the end and the scale would start a little bit further in, so just make sure you read it carefully. But that measurement there is 5 centimetres. Okay, so we've done all the measuring, so we can pop those out the way. Let's see what it's asking us to do. We need to give instructions. Now hang on a moment, there's a key piece of information we've missed here. We haven't worked with the key. So what it's saying, if we put it into a key format, into scale format, the map, and then that's the real journey on the right hand side. The map or the drawing or the scale drawing is always on the left, and the real for right. So real for right. Okay, so that means that 1 centimetre on the map represents 1,000 meters in reality, and if they're going to walk 5 centimetres on the map, they're going to walk 5 times 1,000. So they're going to walk 5,000 meters. It doesn't ask you to specify meters or kilometers, but let's also put down kilometers just for a bit of practice. So you're dividing by 1,000. Okay, not required for this particular answer. Have we got all of our marks? Well, we've worked out the bearings, which is good. We've worked out the distance. We've converted that distance to the real distance, but we haven't yet written our instructions, so we wouldn't get our 4th mark. So the instructions would be to walk 5,000 meters on a bearing of 110 degrees from point A. And that would be our instruction and would get us 4 marks. If you want to pause the video to read that through again and process the information, feel free to. I'm about to move on to the next slide. So on the screen, we've got 4 questions and there's another 4 coming shortly. Pause the video at this point to give yourself plenty of time to answer the questions. But I will now continue and assume that you have paused it and are replaying. So what is the bearing of the compass direction northeast? Now just to do ourselves a little sketch. There we go, I'll put the answers up there for you. Okay, our north is up, our east is to the right, and we know that the angle around to the east is 90, but as a bearing, it's 0.90. And the halfway point between the two of those is half of 90 degrees, so that's 0.45 degrees. Really important, bearings are always 3 digits. Okay, that's really important to know. You could lose a mark in a question if you don't write it in the correct format. Question two, what is the bearing B from A? Remember that we're working from A, so that's why we started here and we use this north line. So that's the point that we measure from, and that has given us the 80 degrees. Okay. The next question, we're being asked for, what is the bearing of B from A? A is on the right hand side this time, so what we're actually going to do is we're working around this way, but we keep going until we meet our direction line. There you go. All right, and I don't know if you remember from our examples last time that this one here is what you would take off of 360 to get the angle that we're looking for our bearing. So that's 360, take away 70, gives an answer of 290 degrees. So the bearing for that one is 290. You can pause the video at any time or rewind it if you want to go back through any questions. So let's have a look at this one. It steps up a little bit in difficulty, but we have gone through all the key facts that you would need to answer this question. What is the bearing A from B? So once again, let's get this correct. So we're working from B, which means we're starting at this point. So that's the north line that we're using. So it's from there that we go clockwise. So we're going around clockwise, which means we're going that way. Now, last time when we looked at the question over here, we had an angle that we could use. At the moment, we don't currently have an angle. Our angle's blank. So we need to see if we can work this through ourselves. So we need to work out this angle. What we do have is we have this angle. And this is where one of the rules that we mentioned earlier comes into play. The sum of these two angles adds to 180. So if I have 180 and I take off the blue angle, take off the 21st is 160, take off another 5 is 155. Be careful that you do that accurately, because when you do that in your head, quite often I'll see an answer of 165 there, which is incorrect. So take off the 21st and then take off the 5. So the pink angle is actually 155. So if we're looking for this angle here, we're going to do 360 and we're going to take off the 155. Okay, so if we take off the 55, that's 305, take off another 100, and the angle is 205 degrees. Again, pause the video here. If you want to replay anything, do so, or pause it and make some notes. Okay, I'll just write that 155 in here so you can see where we've got that from. So I'm going to move on to the next set of questions. I'll read through these 4 questions and then you can pause it if you want to give yourself more time. So the red one is, what is the bearing of the compass direction west? The yellow, what is the bearing of B from A? Green, what is the bearing B from A? And blue, what is the bearing A from B? So please pause the video at this point if you want to give yourself plenty of time to go through it. Okay. For someone that wants to mark the questions quickly, here are the answers for you. And I will go back a slide and walk through step by step for those that would prefer a more detailed explanation. Okay. So on this one here, we'll go back to our compass directions that we had before. We have our north, which is our most important one. East is this way, south is that way, and west is that way. And as we work clockwise all the time, we go round that way, and it's 3/4 of the circle. So that's 90, that's another 90, and that's another 90. If you need to do it that way, then go ahead, but that bearing for the compass direction west is 270 degrees. From north is implied in that, but if you give a bearing of 270 degrees, it is assumed that you know that that is from north round to west. Okay, and we'll look at the yellow one. What is the bearing B from A? We're working from A, and A is on the left-hand side, so that's our north line. So this one is a case of identifying it. So we're going off the north line round here, and we've been given that as 40. But so far we've only got an angle. You need to remember that we need to put the 0 in front to make it a bearing, bearing 3 digits. Very important. Okay, let's have a look at the green one now. So on the green one, we're looking at the bearing of B from A, so they're leaving A to head over towards B, and A is this one here, so we're using this north line here, which means that we're going to go from this one clockwise round that way. And we haven't got the angle for that, they haven't given that to us this time, but what they have given us is this angle here, which is the part we don't immediately need, but we can use that. So we're going to take the whole circle and we're going to take off 95 degrees. And that gives us an answer of 265 degrees. And that answer is complete. Again, feel free to pause the video or replay that if you need to run through it. And now we look at the blue one, which is the harder of the 4 questions. So very similar to the slide we went through just now. Okay, so this time we're working from B. And B is on the right-hand side, so we're going to use this north line first, which means that we're going to measure round clockwise that way to that one. Okay, now last time we were given an angle that was really helpful, but this time all we have is a blank space. So this is where we go back to that other factor that we were told before, that this angle here, the 130, which is I'm going to put in blue. So the blue angle and the green angle are in an interior space, so co-interior in terms of GCSE language. So those two are in the same internal interior space and they add to 180. So 180 take away the 130 means that that green angle has a measurement of 50 degrees. Okay, so the final part of ours is we want to work out this area here that goes all the way around. So we take the 360 degrees, we take off the 50, and that gives an overall bearing of 310 degrees. And that's the end of the lesson.